For number 10, we're going to convert 140 degrees to radians, and then we're going to be doing some conversions. The thing we have to remember about conversions is that we use a conversion factor. So we have to find two places, or a place where degrees and radians are equal. Now, yes, you could use 360 degrees and 2 pi, uh, but maybe an easier one is that pi and 180 degrees are the same thing. So what we get is we get two conversion factors. We get pi over 180, which, since these two measurements are the same, this is equal to the number 1. It's 1. Anything divided by itself, right? 5 divided by 5, that's 1. That's why we cancel it. Sort of when we're doing things, it's equal to 1. Pi over 180 is equal to 1. When we multiply by 1, we don't really change the number. The other one we're going to use is 180 degrees over pi. So these are both, again, equal to 1, but they will convert from degrees to radians and radians to degrees. So when we want to convert from degrees, so we've got 140 degrees, that's in the numerator, right? We have to multiply by the conversion factor that has the radians in the denominator, so we can cancel out the degrees. So the degrees are going to cancel here. I can do this. Degrees divided by degrees are 1. And so we end up with 140 pi over 180. Now, this can be reduced, yes. So we'll go ahead and reduce it. 10 goes into both of these, so we can get that out. And then you can see 2 goes into both of these. 2 goes into 14 7 times. 2 goes into 18 9 times. So that's our answer. Okay. When we want to convert from radians to degrees, we take the same approach. Just get a little bit more room here. We take our radian measurement, 13 pi over 10. We need to multiply by one of the factors that has the radians in the denominator, so we're going to use this one, 180 degrees over pi. And then when we multiply, you just multiply the top and the bottom, so we can see the pi divided by pi, because this is all multiplication, will cancel out, become 1. 10 goes into 180 18 times, and so we're left with 13 times 18 degrees. Which we are going to put into the calculator, because you don't want to leave a number like that. 234. There we go. Write that again. I don't know, my tablet seems to be maybe it's not the tablet, maybe it's the operator is just not being real clear. Okay, there we go. Now, the second part, they define a new unit of measuring angles called a Hoki. And I guess it was invented, so maybe it's not just, some random thing, but they took and divided the circle into 234 Hokis. So one circle is 234. One circle is also 2 pi, and it's also 360 degrees. So what we're going to need to do, if we're going to, we've got degrees here as radians. So basically, we're going to look at that 2 pi is equal to 360 degrees, which is equal to 234 Hokies. I don't know, we'll put a little H here. Make up our own little unit, abbreviation, whatever you want to do. So these are supposed to be C through F. My numbering, because I've converted it over, is a little different. So this actually C, D, E, and F on your tests. What fraction of a circle's circumference is cut off by an angle of 123 Hokies? Well, we know the full circumference would be 234. So if we've only got 123, what would be the fraction? It would be 123 divided by 234. Let's see, will that reduce? Probably not. But we could also, 123 divided by 234. It's a decimal, a little bit more than half. The other thing we can do, let's see, if you go to math, you can go change it to a fraction. I think, yeah, it tells us basically you try to change it to a fraction. Let's see, make sure that works. Do this one here. Oh, 41 out of 78. So there's a nice way to kind of reduce, because that would have, so it does reduce. 41 78. I think must be 3 can probably go into both of those, and maybe 6. Anyway, reducing, I like, just use the technology on something like that. It's not that. So then an angle whose openness is 45% of one full rotation has a measure of how many Hokies? Well, 45%, it's not 45 degrees, 45%. We would multiply by 0.45, because 45% is really 45 over 100. Okay, so we're going to multiply by 0.45. And what are we multiplying by? Well, it's of a full rotation. Full rotation is 234. Okay, again, 0.45 times 234 gives us 105.3 Hokies. 105.3 Hokies. Convert degrees to Hokies, 101. So we've got 101 degrees. So we're going to need to multiply by the conversion factor that will have degrees in the denominator. So we're going to go with 360 degrees. And that's going to be 234 Hokies. Okay, so the degrees are going to cancel. We're going to be left with Hokies. We just multiply straight across and reduce. So 101 101 times 234 gives us 23,634 divided by 360. Notice the degrees are gone, so we just then take our answer, divide it by 360, and we get 65.65 Hokies. convert 101 Hokies to radians. So we have 101 Hokies. It's in the numerator. So we need a conversion factor that has Hokies in the denominator. It's, all the way around the circle is 234 Hokies. With radians all the way around the circle is 2 pi. So that's going to be, we multiply straight across and divide. Um, let's see, they want us, a lot of times with pi, they like us to leave it that way. So let's go ahead, that'd be 202 pi over 234. Again, the Hokies have canceled, the units of Hokies have canceled. So that's gone. And let's just see if 202 reduces to 202 divided by 234. We want our answer as a fraction. So let's do this function. So that's math, and then change it to keep it as a fraction. Yeah, it does reduce to 101 over 117. We could have probably seen that because 2 goes into this. So our final answer here is going to be 101 pi over 117. That many radians. You could also, I don't know, let's see, what do they do here? I just check the answers, see what the answers have. Yeah, they have it as a decimal. So actually you could just 101 pi divided by 117, 2 point. So they've got their final answer in decimal form, 2.712, rounded to 3 decimal places, whatever they need, right? Or you could have the 197. That's question number 10.